All right, what's good, y'all? You already know what to do. It's your boy B Phil, and it's time for some review. So, what I want to talk about today is networks and just the fundamentals of the computer. Well, not that deep, but let's talk about networks, how everything gets moved around the interwebs. Let's jump into it. So, what we're going to talk about first is the basics, right? What is a computer network? And effectively, it's just a network of computers, right? Self explaining the actual terminology. And so when you think of a network of things, you think of things that are in a net that work together. All right, so my explanations aren't too good. Let's just explain it visually, right? So computer one talks to computer two and vice versa. So this is a very basic network, right? Network of two. Now, if we wanted to look, let's say your house, right? This is the crib or the house, and you have a computer, you have a cell phone, you might even have your dishwasher, and these are all connected via your router. And now, this router is typically owned by CenturyLink, Verizon, right? CenturyLink, Verizon, Google, whoever else is giving you internet, right? So this is typically owned by them. And for all the nerds out there, this is high level. This is for normal people. So you can just go somewhere else. So with router, boom, you have a router. And typically what this looks like is you have, or your internet service provider probably has contracts and works with other people, but somewhere down the street, there's probably some other router and some facility or some area where that's sending information here, and that might even have some computers here that are doing some stuff, or maybe this is the homie's computer down the street if you got the public IP address of this route, or maybe it's just a stop in between. Then maybe you have the internet service provider's headquarters where maybe some stuff routes through there. Then maybe they even have some routers in another state in some facility, and it all goes full circle. The idea of the router is just that. If you go on a paper route, you're doing going to a very specific destination through various specific streets, if that makes sense. So this is maybe Poplar Street going down to Park Street, and then we take a right on Fifth Street, and then we make it to our destination. So that's the very, very basics of what a computer network is, what happens in between. But what we're going to focus on is something like this today. So let's just go ahead and jump into that. All right, so what we're going to do is we're going to bring up a browser. Cool. And we're going to go to this website. It's going to boot up. And you can follow along by going to learn.bpdata.io. And it's going to adapt to your system. But what we're going to build is a virtual Ethernet between two computers with a switch that talks to a third computer. Now, you don't have to be afraid. I want to just quick disclaimer, because some people's eyes might glaze over at this particular point, and you might want to feel like you want to stop trying. I encourage you to just click this track one and follow along with me. All of these commands, right? I'm going to explain them. You don't have to do them locally, but I encourage you to do them locally. All the ones that are going to show up in this terminal, so that you get a feel for what it really feels like on your actual computer. With that being said, we're going to jump into track one, and we're going to set up our environment. And so with this particular guide, I've made it so you just kind of get a feel for what's going on here. And so step one, we're going to type PWD to see our current location. So PWD stands for Print Working Directory. Don't worry too much about what all this means. There will be some descriptions here, but the idea is that this isn't something scary. This is something that you have to minimally memorize to get this done. And it should just spark your curiosity about how these things work. Hopefully, if you're the type of person I'm actually targeting. So we're in users and whatever your name is. So you in this case. Now I'm going to ls, or that stands for list. So we show all files and folders in your current location. And so what we're going to do now is we're going to change directory, or just change to another folder. And we're going to go to our home directory, which is the squiggly or tilde if you're fancy. And it's going to go to our home directory. And so on Mac, for this example, what it's going to have me do is install Lima. Cliff Notes is it's just a way for me to run Linux in my Mac setup. And so I'll go brew version, and all this is getting the actual software Lima. So like if you had a CD, you put the CD in the drawer and it goes ahead and installs stuff on your computer. You go to google.com or you go to your favorite video game website and you even click download. This is a similar concept to that. And so brew is basically that. So what I'll do here is I'll go brew install Lima, and what it's going to do is it's going to install Lima. And so as you can see here, Lima spins up a headless Linux VM, which stands for virtual machine. So the computer you're working on is a physical machine or physical hardware. Inside of that physical machine, you can go ahead and say, hey, I have this chip or this stick of RAM that's really big, let's say 16 gigs. I want to go ahead and chop that up and give it to something inside of my computer that works just like my computer. That's all this is. It's a computer within your computer or a virtual machine, and that exposes the same kernel networking tools. And so when it says kernel networking, just think of that as like the heart that basically pumps blood across your entire system. Well, maybe not the heart, the actual brain, because it can send signals and it knows how to talk to everything within your body. Okay, so this is more the brain, not the heart. Scratch that analogy. So then we go ahead, limactl, start default. And the reason why we're going through this, if you're on Windows, you'll see something slightly different than this if you're on this website. And if you're actually using Linux, you'll see something probably more strict to the point. But if you're on Mac, we're trying to get you into an environment where you have the same controls as everyone else to understand this. And one of the ways I think is the most simple to understand it. So we're going to type Lima. And so now I'm inside the actual virtual machine. And so I can say uname -a, and it'll say here, right, it'll tell me what this actually is. So like Ubuntu 21, and it'll tell me some kernel version, brain version, just think of it like that. Okay, cool. You see the version string you're in. So then you want to go ahead and verify your environment. So we're going to create a temporary network namespace. So just think of this as a space for your network, right? Just think of this as a box. So you can just copy and paste this command. I recommend typing it out. So there's some knowledge here, like the sudo super user do. This is, just think of let's say admin, or you're the big boss at your job who has the keys to the actual warehouse, or let's say fast food chain. If you work there, you can open up all the doors that other people typically can't. That's what sudo allows you to do. So we're going to say sudo IP netns add sandbox -test and run this command after the first one. And we'll say IP net namespace, and then we'll list the actual namespace we just created. That's this net namespace. And then after that, we're going to go ahead and delete the namespace. So we'll say sudo IP net namespace del sandbox test. Now, what I want you to do now is I want you to pat yourself on the back. If you didn't know the terminal before, now you know the very basics of working in a terminal or command line environment. So I really, really, really want you to stop and get up and, hit the, hit some dance moves on it real quick and pat yourself on the back because you made it this far, and that's something to celebrate. So let's go ahead and jump into track 2. And this is where we're actually going to configure the network itself. So right now we're in Linux. So if we're on Mac, we're in Lima, right? If you're on Linux, you're in the actual Linux. And if you're on Windows, you're probably in Wazel or Windows subsystem for Linux. And so we're going to focus on creating virtual Ethernet cables to connect our virtual network devices. So a VETH or VETH, as we're going to call it, pair is two interfaces linked together. Now, interface, think of like this cell phone. The general cell phone, you could say, is an interface to talk to people. So whether it's Samsung or it's Apple, the cell phone is an interface for what? Communication between who? Two people. This here is going to link two interfaces for what? Communication to do for who? To talk between two computers or more computers. So data in one end comes out the other, like a physical patch cable between two devices. So you may have seen an Ethernet cable. If you haven't, it's just a physical cable that you connect your computer, your router, or any other physical computing device into something else that's a computer in a way. So you probably connected it from your computer into the actual router that your ISPs provided you. So like you're playing Call of Duty and you want those high speeds, you may have connected it that way. So what we're going to do first is we're going to say sudo IP link add. And what we're going to do is we're going to add an interface, right? So veth0 and its type virtual Ethernet. So this is just a cable, right? So veth, and we're going to say it's type peer, and we're going to give it a name, veth1. So as you can see here on the right, we have a veth pair. So we created veth0 and veth1. So now they're linked, right? Anything sent into veth0 comes out veth1. Cool. So now we can say IP link show. So you can see here we have two interfaces. Boom, veth0, veth1. Now you don't have to worry about this broadcast, multicast. These are, I'd say, basic that you need to know eventually if you want to go deeper into this. But the whole idea of this is just so you understand what's happening underneath. So what we'll do now is we're going to go ahead and create two virtual computers. And so we created the interfaces. So the interfaces, now we have to connect them to computers, right? So we can create these two computers or network namespaces. And each namespace has its own isolated TCP IP stack. All TCP IP is a addressing scheme for communicating over a large network. Think of the internet. So we'll say sudo IP netns add, and we'll say PC1. So we just created this PC1 here. It's an isolated network namespace, so it has its own routing table. And as we've shown in the previous diagram, there's a router, and each router has a routing table. And so we're simulating that right now, where we have a PC that has its own routing table, so it knows where to send information when we're trying to talk to someone. So sudo IP netns, and we're going to add PC2. So we have another isolated namespace. So we have two virtual computers and they're completely separated. So now we want to go ahead and just plug in the cables into these computers. So we'll say sudo IP link set veth0, and then we're going to say put veth0 or veth. So as if we scroll up, we saw we created veth0 up here. So add veth0 type, and then the peer is going to be veth1. So it's going to be the other side of that connection. So now we're just going to go ahead and add, or we're going to set that link to the net namespace PC1, or we're going to connect it to PC1 computer. So now we're going to do the same for the second PC. So link set, and we're going to say veth1, net namespace PC2. So now we've connected both of the cables, PC1 and PC2, but they can't talk because they don't have an actual address. So there are namespaces, right? So when we said the namespace, we called it PC1. This is like on your computer. But in order to talk over these connections, we need to have an address so that when we talk to the other side, they know who to send it back to and vice versa. So what we're going to go ahead and do is, so let's go ahead and explain this. So for two nodes, the cable is enough. But for more, you need a switch. So Linux bridge. Okay, so it seems like this demo actually skipped us a part, but it's cool. So sudo IP link, and we're going to add a bridge. And think of this as a switch. Now, this concept is, I'd say, for the normal user, you don't typically come across these too often, but these are one way that you can, let's say, segment your house. So maybe you have a big house. Let's say you have a big house. Maybe you don't, but this is probably where it only makes sense. Is you have a big house, you got this intermediate switch, and this intermediate switch, it looks like your router, but what it does is it operates on a different layer of the network stack. Now, all of that to say, that is particularly used for segmenting or extending your network to other places. So segmentation and extension are some of the primary use cases when it comes to physical lines. And so what we're going to do now is we're going to create a link. So we have the software switch, and it's going to learn MAC addresses and forward traffic between connected ports. And so that's what I was talking about. When we talk about talking over the internet, you typically have an IP address. And when you talk over switches, you typically use the MAC address to forward traffic to devices on specific ports. Now, MAC addresses are another concept where it's the physical hardware address. So inside your computer, you have some network adapter, probably a square or rectangle, more than likely a rectangle, and that actually has a burned in address on that particular piece of hardware. And so that is used to communicate across switches or MAC addresses. Now, there's a whole protocol for this. There's a whole separate course or really understanding that you have to pick up for it. But for now, we're just going to stick to the high level. So sudo IP link, and we're going to set BR0, and we're going to bring it up. So let's go ahead and create a new cable for PC3. So PC3 is going to be connected off of this bridge. So we'll say sudo IP link, add veth2, and we'll say type virtual ethernet or veth, and we'll say peer, and then name is veth3. Okay, cool. So 2 to 3. So we want to plug that veth2 into the switch or bridge. So sudo IP link that veth2, and then master BR0. Cool. So we now have the port on the bridge, and so the traffic from veth2 will be switched to other ports. So now we're going to create PC3 and plug in the other end. So we'll say sudo IP net namespace. Remember, we're creating a namespace that has its own TCP IP stack. We'll say add PC3, and we'll do some chain commands. So sudo IP link set veth3, and we'll set it to net namespace PC. Cool. So now we have these two connected. Now we'll switch traffic over the bridge, or in more common terms, the actual switch. So we create PC3, and so now we want to assign IP addresses to make the network alive. So TCP IP, or excuse me, IPs on these. So let's go ahead and add an IP address to PC1 and power on its interface, or bring the interface up. So sudo IP net namespace, and we're going to execute exec on PC1 IP adder or IP address, and we're going to add one. We'll say 10.10.1, and again, the actual addresses is a whole different topic to discuss. There's private and public addressing. Right here, we happen to be using the private addressing space, which is fine for this lab, but this is another discussion if you're interested in that. So veth0. So we're gonna add an IP address, and we're gonna add 10.0.0.1 in the subnet of 20/24, and on the device veth0. And if you recall, we connected veth0 to PC1, so it's on this particular interface here on the left next to PC1. Boom. So now we've assigned that IP address. So let's go ahead and bring up the actual link. So sudo IP net ns, and then we're going to exec or execute PC1 IP link, and then we're going to set veth0. Cool. Now there's power to it. Now we can have packets going across that particular line. Now let's go ahead and assign an IP address to PC2. So sudo IP net ns exec PC2, and then we're going to go ahead and IP, right, adder or address add, and we're going to say 10.0.0.2/24. This is going to be the subnet, and we're going to say device, and if you recall, the device here, veth1, boom, and then we're going to do a chain command. So sudo IP net ns, and we're going to exec PC2 IP, and then the link we're going to set veth1, and we're going to put power to that interface. Boom. Now we want to test connectivity. So again, we're going to go ahead and run an exec or execute on this virtual space, right? So PC1, so net ns exec PC1, and we're going to ping, and we're going to do it 3 times -C, and we're going to try and talk to PC2. And this is what you should see. And then you see things are flowing to PC2. Great. Okay, so congratulations. You built a working virtual network from scratch, y'all. Now, I really want you to celebrate this achievement with me. So, real quick, go ahead and hit a dance move. Make yourself flow a little bit. Yeah. Okay, so this is a very important milestone because now you understand the fundamentals of how networks actually work. And that's important because when it comes to the digital world, the more you know, the more you grow. And I just want you to know I'm proud of you. So, without further ado, it's your boy B Phil. You already know what to do. We already did some review. And so I hope you go out there and build something cool and have a wonderful day. Peace.